Hi, I'm Lou Signorelli with the Electric Power Division's Systems Integration Engineering team. Today, I'm here to talk about UPS topologies. Today, we'll work through an overview of common UPS components, a look at the market for UPS topologies, and a review of the benefits of different UPS topologies as well. If at any time you have a question, please feel free to use the comment box located just beneath these slides on this webpage. An email will be generated and sent to my email box, and I will do my best to write back just as soon as I possibly can. When we look at the individual components, the first component I'd like to talk about is the rectifier charger. When we talk about rectification, we think about changing AC to DC, and that's exactly what we're doing. The incoming AC power is converted to DC voltage to put a charge on the batteries and then fed over to the inverter. When we talk about inversion, it's about turning things upside down. Exactly. We're talking about taking the DC current and taking that voltage and making it AC. And we're going to do that. The inverter is going to use a pre-established reference point to create a perfect sine wave output. When we talk about power sources, we're going to talk about power sources that provide backup power to the inverter. This could be flywheels. It could be any number of things, batteries. There are a host of different battery technologies currently in use, and alternative energy storage devices coming on all the time. When we talk about bypass, this is a path that allows the input power source to power the load while bypassing the rectifier inverter. This is important for both handling failures within the UPS itself, as well as making the UPS more, shall we say, field service tolerant. In other words, a technician can more easily get into this UPS now and provide technical support. Filter, both active and passive. We're talking about power conditioning, maybe filtering for harmonics, any kind of voltage anomaly. When we talk about filtering, we're talking about removing those from the power path. So power conditioning is the act of correcting some or all of the 9 power problems. So you ask, well, what are the 9 power problems? On this chart, we show the 9 typical power problems, from a complete power failure to the more complex harmonic distortions. Your UPS at the best level, and when you talk about good, better, and best, you talk about some UPSs, typically standby UPSs will handle 3 of these. Some of your mid-level UPSs will handle up to 5 of these power disturbances. At Caterpillar, we like to focus on UPSs that handle all 9 power problems. So let's talk about topologies for a moment. Passive standby or offline UPSs, the backup power is not connected to the load during normal operation. It is switched to the load when the input power fails, and there's very little power conditioning going on. Typically, you don't see this kind of UPS used in data centers where there's a lot of sensitive equipment being operated. Line interactive UPSs, I call them somewhat of a hybrid UPS because they are connected to the load at all times. The backup power is always connected to the load. The inverters are always connected to the output, however, just not in the primary path. So as different anomalies, power outages, different power conditions present themselves, the UPS is able to adapt and react. Lastly, double conversion or online UPSs, the backup power is always connected to the load. It is connected to the load in its primary power path, and it actively conditions it, as we mentioned a moment ago when we were talking about rectifiers and inverters. The double conversion UPS converts the power all the time. So all incoming power is converted from AC to DC and then back from DC to AC to create the perfect sine wave output all of the time. It also adds an additional layer of isolation, input to output. So let's take a look at what this looks like more in a one-line type diagram. The normal power path for a passive standby UPS would be through its input disconnect, through the filter, into the output switch. A portion of that input current is going to be brought down, converted from AC to DC, so that we can keep a nice charge on our batteries. When presented with a power outage, the UPS will switch over, draw power from its battery, convert that DC to AC, and out through the output switch it goes. In a line interactive topology, we see the normal power path passing through the static switch, the line inductor. Through the combination of the line inductor and the filter inductor, we can do some power conditioning and scrubbing of the power and make sure we get a nice, clean output sine wave. We're also making sure that our battery or flywheel, in this case, backup power supply, also remain charged and up to speed. When presented with an outage, the flywheel assumes the load instantly, passes the output power through our two converters, through our filter inductor, and out to the load, thus supporting the load and giving us time to transfer the power to our gensets, which are currently coming up to rated speed and voltage. Once they reach that speed and voltage, the UPS intelligently transfers that load onto the gensets. In a double conversion topology, the power passes through our rectifier, changing from AC to DC, puts a charge on the batteries, then back from DC to AC, and a perfect sine wave output. When presented with an outage, the batteries continue to provide power to the inverter. Thus, the inverter changes from DC to AC, that voltage, and out to the load in a perfect sine wave output. No switching, no conversion, just simply passing the DC through the inverter, creating AC output, and on to the load. So in review of the topologies, when we talk about, there's a few more terms I want to review. We talked about double conversion. You also hear the term online. They're often used interchangeably. There's a little difference in the definition, however. An online UPS means that the inverter is connected in series with the AC input supply voltage. The UPS inverter is active at all times. So as we saw in the double conversion one line, that inverter lies in the main power path. Offline or passive standby, also used interchangeably. The UPS inverter is connected in parallel with the AC input. So not in the main power path, but in parallel to it. The line interactive is exactly what the name implies. The UPS has its inverter connected in parallel to the AC input. However, the inverter is active at all times. So we have a line interactive UPS. Thank you for your time today. Again, if you have any questions, please use the comment box found below. Thank you.